Before we can move on to implementing a DFS, we first need to look at how we might represent trees in our code. Now, this section might be a little bit confusing towards the end, but I think it's important to sort of follow through with it because I want to give you a way to read different types of trees in your code rather than just having the same tree and using it in every example. I want to be able to give you a couple trees that you can actually test your code and see if it works. So in this section, we're not only going to show what code I would use to represent the tree in our code, but we'll also go over a file input format that we can use to, read the different trees, and that way we can work with many different trees, make sure our code's working correctly, and really get a feel for how that works. So we're going to start with just how would we represent a tree like this in our code. So you can see that this isn't obviously, it's not like a complete tree. There's not a leaf for every single node, but there's only just 4 nodes in it, and we've got this root node of 8, and it has 2 children, the 4 and the 12. And then the 4 has 1 child, the 6, but it doesn't have a left child. And the 12, on the other hand, has no children, same with the 6. So the first thing I want to note is that each vertex or node has a value. In this case, they're all integers, so we're going to move forward just assuming they're integers. So we're going to create this type node. It's going to be a struct, and it's going to have a value field that represents the integer value. Now that's pretty easy to get by. The next part we're going to talk about is a little bit harder, and it's how do you represent these children for each different node. So this 8 has 2 children, and we need to sort of represent that. So to do this, we're going to have a left and a right child in our struct, and they're both going to be pointers to node. The reason they're going to be pointers is that there are cases like the 4, the 6, and the 12, where one of these children might not be present, and in that case, we need to represent it with nil. So you can see here that 4's left child is nil, 6's left and right are both nil, and 12's left and right are both nil. So by using pointers for these two values, we can set them to nil whenever one's not present. The leaf nodes are the easiest ones to initialize and to visualize at first because they don't rely on other nodes being present. You can see here in this code snippet that we can construct this 6 node really easily because we just set the left and right to nil and we don't have to have any other nodes present. Other nodes like this 4 are a little bit trickier because we either need to have the 6 node already instantiated when we create the 4 so that we can assign that, that link on the right hand side, or we need to assign it after the 6 has been created. So in this case, we create the 4 and it has a value of 4, and then we create the 6 node and it has a value of 6. And then after all the nodes are created, we set 4's right-hand child, so 4.right, we set it to 6. So in this case, the pointer on the right-hand side is now pointing to the 6 node. So as I said, rather than hard coding out this graph and doing like we did right here in this example, rather than doing a bunch of code like this where we have to manually create every single node, we're going to look at a way of reading in an input file and being able to create a graph from it. So I'm going to go through all of this here in a moment, and I've tried to color code it a little bit. And if I assume that some of you might be colorblind, and I apologize for that. I'm going to try to use arrows and talk and highlight things so that it's a little bit easier to follow along. But I'm going to do my best. But what I want to show you is that the sample input on the bottom right is what we're trying to create. This node has, or this graph has 5 nodes. They have the values 1, 2, 3, 4, and 6. So you can see here that 4 has 2 children, the 2 and the 6 values, and 2 has 2 children, the 1 and the 3 values. All right, so reading through the format of the data, the first rule is that the first number we're always going to get in our input is n, and this represents the number of nodes in our graph. So you can see here that this n number is the number 5, and it is the total number of nodes in this graph. You can see here that we have 1, 2, 3, 4, 5 nodes, so it's going to be a 5. The next 5 lines, and they're going to be n lines, so whatever this first number is, there's going to be that many lines following it. So in this case, there's 5 lines, so 1, 2, 3, 4, 5. The next 5 lines of input will each have 3 numbers on them. The first number is going to be the value of the node, so in this case, the 1 is the 1 for this node here. The 3 is the 3 for this node here. The second number is going to be the index of the left child. Now this is important because the index isn't going to be the value of the left child, it's going to be the index in this order of items we're getting. So if I click here, you can see that assume that the index starts at 0, and then the index goes to 1, then the index goes to 2, then 3, then 4. Now these index won't be provided to us, they're not in the input file, but you can assume that when you're starting to read through, you could write a for loop, so it says for I equals 0 to 4. So you can say that the first line is going to be index 0, the second line is going to be index 1. So in this case, if we click through this, you can see that this first line of index 0 is going to map to this node here. So it's got the value 1, and that's what these indexes for. I do want to stop and just take a second. I should have covered this earlier. The first number is the value, the second number is the index of the left child, and the third number is the index of the right child. So when they're -1, assume that there are no children, because -1 is not a valid index, so just assume that there are no children in that case. That's what this bottom rule says. So in this case, we're saying the first index is 0, so our first node is at index 0, has a value of 1, -1 on the left side, so no children on the left, -1 on the right, so no children on the right. So then we go to the second line of our input, or the second line of the n lines, and it has a value of 3, and since it has -1, -1, it has no children. So that's this node here. Then we move on to the index equals 2, and in this case, the value is 2. That just happens to be the same as the index, but that was just luck. And then the index of its left child is 0. So you can see up here, the index of the first one that has the value of 1, that's where it's getting this 1 from, the left child. So it's saying point to this first line of input, that's the one that you're going to use for the left child. And then its right child is going to be the index 1. So in this case, this 3 value is its right child. So then we get to the index equals 3, and in this case, the value is 6 and it has no children. Lastly, we get to index equals 4, and this happens to have the value of 4, and its left child is the item we read with index 2, and its right child is the item we read with index 3. So index 2 is this number 2 here, or the one with the value 2, so that's how you see this left child. And index 3 is this one here that has the 6 value, so that's how it got the 6 over here. So here's where I'm trying to show you visually that this 2 points to this line up here that has index 2. And it happens to be the one with the value 2, and then the left and right children of indexes 0 and 1. So I'm going to say let's go ahead and try coding this. We will take the sample input file, and we'll also write a function real quickly to print out what we're doing so that you can actually see, what's going along the way. So let's try coding this to see what we get. We're going to take the same sample input file, and we're going to use that to try to create our graph. But before we do that, I'm also going to want to create a print function that will allow us to print out each of the items in our graph so that we can sort of visualize it to see, is this reading correctly or is this working correctly? Because it's always nice to have a way of sort of testing out what you're doing, and it's hard to print out a graph like this. It's much easier just to print out the numbers and to say what its left and right children are. So I'm going to copy all of these numbers, and I'm going to I'm going to first do dfs.in. So this is just our input file. So this is what we've been working on. I just put the 5 on the first line and then all these other numbers going down. So this is just going to be our input file, but right now we don't need that. First, we're going to start with package main, and then we need to create this type. So we already did the type in the slides, so I'm just going to sort of go through this pretty quickly. We've got the value, which is an integer. We've got our left child, which is a node. We've got our right child, which is a node. So we can save this. The next thing we want to do is we want to just go ahead and write a print function that prints out a node and makes it real easy for us to do that. So we're going to say func print node. It's going to take in a node, and it's just going to print out something into our terminal that sort of helps us see what the node is. So the first thing we're going to do is format.print n.value. We always want to see the value of our node, so we're going to put value and then n.value. We also want to put a new line after every single print. So I'm going to put this at the very end because we're going to have a couple other lines of print on the same line. So from here, I'm just going to go ahead and test this, which means that we need to do func main, and we need to create a node to test with. So I'm going to say test is a new node, and we're going to say value is 1, 2, 3. Then we're going to print node test. So let's go run main.go, and you can see it's printing out the value of 1, 2, 3. All right, so we have that printing out. What we need to do next is we need to at least make sure that we're printing out the left and the right child of every node so that we can at least see what those are. We don't want to print out the actual, the pointers here. We want to print out the actual values of those nodes. So I'm just going to show you now. If you do format.print, print line test, this is going to print out nil nil here, which nil is somewhat useful, but if we assign those to anything, for example, if we have right, value is 333, and then if we say test.right equals right, now if we print this out, you'll notice that all we get here is a pointer. It's not really that useful. It's kind of hard to, it's kind of hard to see what's going on there. So rather than, just letting that be, we are going to write a, finish up our print node function so that it'll actually print out what the right and the left values are as we go look at the nodes. To do that, we're first going to have to check, does this node have a left child? So if n.left is not equal to nil, if it's not nil, that means we can print something out. So we're going to do format.print, and we're going to say left, and then we're going to do n.left.value. So we're just going to print out the value of the left child. We don't want to print out anything else. That's a little bit overkill. So we'll just print out the value. So we can copy all of that, and we can change it all to do the same thing for the right. If I could type today, that is. So we have if n.right is not equal to nil, then we're going to print out the right-hand side's value. And then after all that, we'll print the new line. So now we can go ahead and rerun our program. And you'll see here that the fumpt.println line is just printing out the value, nil, and a pointer. But the function that we wrote, the print node function, will print out the value is 1, 2, 3, and the right child's value is 3, 3, 3. All right, so we have a nice print node function. That'll really help us out along the way. So the next thing we want to do now that we have that is we just want to go ahead and try to read in this input file. So assuming you've used some of the ways to read in an input file, I'm just going to kind of go through this. If you haven't ever read in an input file before or anything like that, just go ahead and leave a comment, email me, something like that, and I will try to get you some resources for that. I'm sure there are some online. I just need to find them and link them. So we're going to go ahead and say var n int. So this is going to be the n integer that we're reading in first. I'm going to name it n because that's what it was called in our slide, and I think it's a little bit easier just to keep that consistent. So we're going to say fumpt.scanf. We'll go %d, which is an integer, and we're going to say and n. So we're going to go ahead and print out n after we scan it in, and I'm just doing that to make sure this is correct. So now that we've done all that, we need to run our program, and we need to make sure this works. So you see that whenever I run the program, it stops and it just sits here. So it's doing that because it's waiting for me to type in a number, like 1. So if I type in 1, it reads it in and then it prints it out. So that's the n number it's running. So I showed you earlier that I created this file called dfs.in. I'm going to go ahead and just show you. It's right here. I can ls and show it in this directory. So whenever I have this file, I want to send that in as these, I don't want to type in my input every time. So what I'm going to do is I'm going to type go run main.go, and then with the less than sign dfs.in, this will pipe the dfs.in file as my input for this program when I run it. So you can see here that now when I run it, I don't see the input because it's getting piped in, but it reads in the number 5 as n and it prints it out. So I can even show you that and be like, n is, and you can see that it says n is 5. So it's reading this very first line as 5, and that's what we expected. All right, so we have n. Now we need to sort of go through all of the numbers n. So we're gonna have n rows, and we need to try to create the nodes for every line. So the first thing we wanna do is do var nodes. Node. So this is gonna be a slice of nodes, and we're going to make it ahead of time. So we know that there's going to be n of these. So we're just gonna go ahead and create this slice of nodes, and the length is going to be n. So once we know that, we can go ahead and say for I is 0, I is less than n, I plus plus. So this will give us the indexes 0 through 4. So if I go back here, you can see how I have the indexes 0 through 4. That's how I'm getting the indexes, as I'm writing this for loop, and I is going to be that index. So then on every single line, I'm going to say, I need 3 variables here. I need the value of the node, I need the index of the left child, and the index of the right child. So we're going to do var val index left, index right. And these are all integers. So I'm going to do funct.scanf %d, %d, %d. So %d is just the way of reading an integer. So that's what we're doing here with the scanf. And that's the part that I said that if you don't quite understand it, I'll try to help you find a resource for it. Depending on what language, if you're not following along with Go, if you're doing another language like Java, you might be using something like a scanner and calling nextInt, something along those lines. But if you're using C or one of those languages, you're probably pretty familiar with scanf. So we're going to go ahead and read this in with the value is the first one, so that's the value of the node. The index left is the next one, and the index right is the third value on that line. So we're going to go ahead and print these out. So we're going to do value, val, then we're going to do index left, then we're going to do index right, and then index right. So I just want to go ahead and print these all out and make sure that they're good. You can see here that it's complaining because I'm not using these nodes, so I'm going to comment them out for the time being. I just want to go ahead and make sure I'm reading my input correctly. So we got value 1, index left -1, index right -1. So I'm going to go to our input file. That looks correct. So if I continue looking at these, you can see that all of these appear to be correct. They're matching up with this output or input file that I catted out up here. So it looks like we're reading in values correctly. The next thing we need to do is actually set these values on our nodes. So we need to do, first off, I need to uncomment the nodes, and then I need to do nodes, and then we're at the current index of I, so we're iterating through these with the indexes, and we're going to say .value equals val. So we don't need to instantiate this node because when we went ahead and made this, it already filled these all up with empty nodes. So we have empty node objects. We just need to set all the different pieces on the node. So we say nodes I.value equals val, nodes I.left. So this is where we could run into a problem. What we want to do is we want to say nodes I.left equals nodes index left. But the problem is if index left is -1, this is going to raise an error. So I'm just going to go ahead and, we also need the address to this. We don't just want the node. But if I run this, it's going to result in an error. Something is going to panic. So I'm just going to show you that really quickly. And I'm going to move this print line to the top so you can see which line it does this on. But I just want to show it to you in case you happen to run into this. So we have this panic runtime error index out of range. So what happened is we use this index -1, and that's not a valid index. So what we need to do is we need to say if index left is greater than or equal to 0, which is all the valid indexes we could possibly have, then and only then are we going to go ahead and make this assignment. And then we're also going to do the same thing if index right greater than or equal to 0, nodes I.right equals and nodes index right. So what we're doing here in this part here, this part, I'm going to go ahead and put a space between them. This first part, or the second part technically, is saying in our list of nodes, so in our slice of nodes, we want to get the one at index left. So when we go back here to the DFS, remember how these numbers reference indexes and not the actual value that was stored in that node. So we want to get the one that's in the index there, represented by it. So since all of our nodes are already instantiated up here, we can just go ahead and reference it. Even if we haven't set the value for it or anything, we can reference it because it's already been created. The and sign is just saying that we want to reference the pointer to it, instead of just referencing a copy of it or something like that. So we want to point to the pointer of it. So once we do all of that, we should have our nodes list pretty good. I'm going to go ahead and print line nodes, and this probably isn't going to print out anything useful. Well, the one thing you can look at real quickly here is you can see which ones have nil and nil for its left and right child. So it looks like the one with the value of 2 has 2 children, and the one with the value of 4 has 2 children. So let's go ahead and look here and see if that's right. 4 has 2 children, 2 has 2 children. Nobody else has any children. So that looks like our graph is at least close to what it's supposed to be. The last thing we're going to do is going to do for each node in the range of nodes, we're going to do print node with the node. And we need to get the address to it. Technically, we don't need that, but we could have made this not be an address or a pointer, but that's fine. So now that we have that, let's go ahead and run this. And you can see that I'm going to go ahead and get rid of this line up here. I just don't want that output to be there. So let's run it again. You can see that n is 5. Our first node has a value of 1 and no children. So let's go over here. Value of 1, no children. That looks correct. I'm going to go back to the terminal. Our second node has a value of 3 and no children. So you can see here, value of 3, no children. That looks correct. Our third node has a value of 2 and its left child is index 1, or sorry, has a value of 1 and its right child has a value of 3. So here we're printing out the actual values, not the indexes. So let's look at 2 here. Its left child has a value of 1, that is correct, and its right child has a value of 3. So it looks like that is what we expected there. So now we have the 6 right here. It has no children, and we have the same thing in our printout. It has a value of 6 and no children. And lastly, we have the node with the value of 4. The left child has a value of 2, and the right child has a value of 6. So we go to 4. The left child has a value of 2. That is correct. The right child has a value of 6. So that is also correct. So the upside to this is that now that we have a way to read in these graphs, we should be able to create trees and do our DFSs and our BFSs and actually test them using these graphs that we've created. So I know that there's a whole lot here. What I'm going to suggest is that even if you don't fully understand what's going on here, just go ahead and try to follow along and get the code copied. And then we're going to pull all this code out into its own function. So I'm going to call this func read, and it's going to return a slice of nodes. So the reason I'm doing this is once we get the nodes back, we should be able to write our BFS and our DFS and all of our other algorithms just using them. We shouldn't need everything else from here. So I'm going to go ahead and just say read is our way of sort of reading the input and returning our slice of nodes so that later on when we're writing our code, we can just reference this without having to rewrite it every time. So that means that at the end of this, we need to return the nodes. And then to test that this is still working, we need to do func main. And we'll do nodes is equal to whatever we get back from read. And then lastly, we're going to go ahead and pull this print loop out of here because we don't need to print it out every time we read it. We also don't need to print out n every time we read it. So we'll get rid of those 2 print statements. You can see here that read is just this function now where we read an n, we read in each little line for the nodes, and then we return them. And then up here, we'll go ahead and paste this for loop where we're printing out all the nodes. And we're going to go ahead and just test it real quick. All right, so our output's exactly the same. And that's exactly what we wanted. We just wanted to move some code around and just put it inside of its own function so that moving forward, we can do all of this. And then on this line, we could do DFS nodes, and we could maybe say find the number 1. But we aren't doing that just yet. That will be the next video. All right, hopefully that helps. If you need a copy of all this source, let me know. I'm going to try to get a copy of it on the Go Playground, and I'll try to link it from this video. If you're enjoying this series, I'd really appreciate it if you could head over to my blog at calhoun.io and head down to the mailing list and sign up. So I won't spam you or do anything like that. When you sign up for the mailing list, I will send you a free sample from my book, Web Development with Go. And then I'll send you an email about once a week, just letting you know about new articles or new videos or really any new free content that I'm sending or that I'm releasing, publishing. And I'll also let you know about, what I'm working on in the coming weeks and try to get some feedback on what everybody thinks I should focus on and what they'd like to hear me talk about. And every once in a while when I release a new product, a new course or a new book or something like that, I will send an email out to the mailing list. Oftentimes it'll be accompanied with a free sample or a discount code or something like that. Basically just letting you know about it. And if you like the stuff that I'm writing, chances are you'll at least appreciate some of that. And I definitely really appreciate any of the purchases because they help support me and help me a lot to keep creating free material like this. Thanks so much.